when will this all become real? The power density per rack is just skyrocketing. NVIDIA asked the chips that in another 6 months, they will be at 1 megawatt per rack, right? If you have a 50 volt bus feeding 1 megawatt, you're looking at 20,000 amps, right? So that's not going to work. So that needs to go to 800 volt in order for your power density of your racks to go up. And so the entire ecosystem has to now create solutions for it, right? For example, the DC companies, the companies that make the chips that convert from 800 volt to 50 volt to a GPU voltage, they're all getting the chips ready right now, right? So they're all samples. So by the time they get to production, it will be sometime next year, middle of next year. So I anticipate 2028 first quarter.
Hi, wherever you're listening to this, I hope you're doing well. Welcome to India Tech Report, a podcast dedicated to chronicling and supporting India's rising deep tech and climate tech startup ecosystems. I'm Hari Arakli, and in this episode, Satish Padmanabhan, co-founder and CEO of DIMAAG, unpacks his company's innovations for the critical power infrastructure shift needed to sustain the AI revolution. Satish is a genuine serial entrepreneur, with DIMAAG being his 7th venture and also his longest job, as he jokes. The company's evolution goes from a smart factory quality control platform that verified 220 million disk actuators monthly to designing electric tractors to heavy-duty electrification. Satish teamed up with Tesla veteran Ian Wright to start DIMAAG, and they have notched up deep intellectual property in the area of thermal management. Today, DIMAAG's tapping its expertise to offer solutions such as ZettaWatt, an innovative 800-volt DC platform that reduces disruptions as AI data centers connected to power grids become increasingly power-hungry, driven by surging AI chip power density. We also dive into Satish's views on the physical scalability limits of large language models with current solutions, why hard, unglamorous engineering is making a massive comeback, and his insights into how global investors have begun to take notice of India's deep tech opportunities. Okay, so Satish, thanks for doing this. Really appreciate you making time for this conversation. But just to get us started, you can give us a brief history of how DIMAAG happened, and a little bit of background about yourself and co-founders, Ian and others, and we'll go from there.
Okay. I'm a serial entrepreneur, right? So I came to US study, started my company, first company when I was in college, and failed gloriously. So this is my 7th startup, right? So I've been a serial entrepreneur all my life. Usually it's a 4 to 5 year thing, and then we get acquired or we don't succeed. I'm batting 500 right now, 3-3, which is pretty good in Silicon Valley. Now, DIMAAG we started in 2018, just before COVID, and been around for 7 years. At the time, I wanted to name DIMAAG as No AI. No in Japanese means brain. And I do a lot of collaboration with Japanese companies and whatnot, but they felt that's a little too radical. So they said, can you replace the brain equivalent with more of an Indian word? And then DIMAAG-AI, the domain name was available, and that's usually the most difficult thing to get. And that's how DIMAAG came out to be DIMAAG, right? Been around for 7 years. So this is the longest job I have had in my life. Most of my companies, I think the longest tenure I had was 5 years. But here we are after 7 years, after COVID, everything going strong. We have not even raised a Series A so far, so we are doing something right. We are about 180 people right now and growing both in USA, India, and in Japan, right? So doing pretty well.
Okay. How did you and Ian team up?
Okay, so it's a long story. We started DIMAAG as an AI company, right? Smart factory predominantly. You buy a storage disk anywhere on the planet, you open it up, there is something called a disk actuator that helps you read and write in your hard disk. 100% of it is verified by DIMAAG, right? So we do about 220 million units a month, quality control. So that's where we started, right? That was our first project for AI for automated optical inspection, and then we moved on. Doing pretty well. A lot of Japanese customers, given my background with working with a lot of Japanese companies right from my first company. Then COVID came, right? And it became suddenly impossible to do customer development, right? Because they need to meet you in person to be able to do something. And if you're a startup, no big company wants to work with you, right? So all the big companies like Accenture, IBM, even Microsoft, they could go, get a new customer without, because they have the credibility already lined up. So we found it very difficult. So we said, how about us doubling down on the customers that we already have rather than trying to get a new customer? And at the time, companies like Kubota were our customers. Kubota is one of the tractor companies, leading tractor companies in the world. I was an advisor to Kubota also at the time, in addition to Kubota being our AI customer. And at that point, they were discussing about all this electrification regulation, where states like California are starting to ban diesel or gasoline vehicles being sold here. And so electrification was a necessity for them, right? And at the time, their internal development was a little, time consuming, or, schedule wise, a long ways off, given that they're all big companies. So they asked me if I can build them electric tractor. I've never done anything like that in my life, but we were desperate for business. And of course, I put my hands up and said, yeah, sure, why not? Right. Then we line it up. And of course, one of the biggest benefits of being in Silicon Valley, I think, is that you can reach anybody, right? And you can put together a team which specializes in any specific topic without having any concerns about it. So I got introduced to Ian. Ian, you're used to, before Tesla, you worked for Cisco. And so I know somebody at Cisco who knew Ian. So we had a phone call, and Ian agreed to meet with me, and we met, in Woodside. And interestingly enough, he thought I was crazy, right? Why do an electric tractor of all the things? Right? But then we got into the details, and it was clear that there is both regulatory reasons to do that. And second is that if you're going to do it, you cannot do it the way you build a car, right? The car is a high energy kind of solution, while for off-road vehicles, you need high power solutions. And that's how I met Ian back in 2020, late 2020. And he then joined our team. And now everything that has happened after that in terms of our high power EV solutions, mobile megawatt charging, data center play, it's all Ian's brainchild. Yeah.
So walk us through how you've moved from electric tractors to ZettaWatt. Of course, we will come to what ZettaWatt is as well.
Sure.
But today it looks like that is going to be your sort of big flagship product.
Yes.
And correct me if I'm wrong. But give us a sense of the transition and tell us about where you are at today.
If a company does something right and continues to exist for a long time, there are new business units, new products that start happening, right, within a company. So as I said, we are started on the AI side, and that AI business unit is still going strong, right? We are still very strong in Smart Factory. We are cash flow positive in each one of our businesses. The second one that we started was the EV business. That was actually because of the COVID necessity, as we talked about, right? But the data center opportunity came right out of the EV technology. So in EV industry, what happens is, you need a battery, you need thermal management of the battery, you need power electronics, and you need system knowledge, right? And all the BMS and all the software control and everything going around with it. Now, the electric vehicles, as you know, already started at a lower voltage, but then they very quickly went to 400 volt operation, 400 volt DC operation, 800 volt DC operation. So the reason to go to a higher voltage is so that you can reduce the current, so you don't have thick copper running everywhere, right? The data center industry has been in 50 volts, and as of today is still operating on 50 volt DC, right? Now, when they are trying to increase the power, and as all these new GPUs and any company, all the semiconductor companies, they're trying to improve the power density of their chips, the power density of the rack is increasing right now, and they're stuck with a 50-volt DC bus. So imagine that, not very long back, the each rack was like only 5 to 10 kilowatt, right? These days, 130 kilowatt per rack is normal. Now we're talking about in beginning 2028, 1.1 megawatt per rack, right? With all the new NVIDIA chips and everything that's coming about. With the same 50-volt bus to provide 1 megawatt, you're going to be having, this thick copper running everywhere, right? So NVIDIA and other companies, they have naturally seen that, oh, what did the EV industry do? Oh, they went to 400 volts, then they went to 800 volts. So, even last year, I think Google was proposing plus or minus 400 volts, and then NVIDIA said 800 volts. And so the 800 volt migration of the data center has already been done in the EV industry. And all the pieces that you need in that migration, we already have, right? Because we are in the EV industry. And that's what lends us a head start trying to solve the problems on the data center side.
Okay. So now give us a sort of overview of what DIMAAG is. You have these different business units. So as of today, what is the company all about? What are your main products and where do you think you're headed towards?
Okay. So each one of those business units has its own journey going forward in life. So I think of DIMAAG as literally like a private equity fund, right? We are owning 3 different businesses, right? The businesses have some overlap, specifically on the business side. A lot of our AI customers are EV customers are AI customers. So we kind of are unified from a customer and a business development objective, right? But in terms of pure technology, AI technology is quite a bit different from EV technology. We use some overlap, but those are separate. The AI products, we have platforms, we have solutions, we have deep deployments in many customers. So that is going to go on its own journey. And in that, we started at the application layer, of course, right? Just basically using, traditional algorithms. It doesn't matter, image, video, time series data, to solve a customer's problem, right? Now we are going a little bit above that, and let's say that we are developing agents that are both beneficial for internal to DIMAAG and for other companies, right? So we are trying to do those new product developments and things like that. So a company will have to evolve, solve newer problems, or try to increase the scope of what they're offering in order to be able to survive. So I think of the AI part of our business to be like that, and it's been around for 7 years, right? There are very few companies, AI companies, that have survived for 7 years, right? The EV part of our business started 2021 in some sense, right? End of 2020, 2021, in 5 years. We have developed a lot of core technology, right? One of the key things is the battery technology. We don't manufacture the battery cell, but we use battery cells from other manufacturers. But how we make the battery cells into a module, into a pack, is our secret sauce, right? When you are using a battery for a low power application, your cooling requirements are not that heavy, right? But if you're using the battery all the time, then it's going to get very hot. And you're seeing, battery fires, even though the best quality engineering has gone into it, cars catch fire, lithium ion batteries are not the most stable batteries if you don't take care of the thermal management properly. So what we do is something called immersion cooling. So there are, a few types of coolings, right? You can do no cooling. Some cars have tried it in the past. You can do air cooling, just blow air through it, or chill the air and blow it through that. You can do liquid cooling, which is basically you make a surface cold, like a cold plate, and then you keep the battery on top of it. What we do is immersion cooling. We take a dielectric liquid and actually flow it through the battery. So it actually touches the battery. And that's the most efficient way of dissipating heat from a system. And so we have developed over the last few years our own immersion cooled battery modules and battery packs. This gives us a big advantage when we are going into this data center applications where some of these requirements require very high power batteries. And this is also needed in the electric vehicles that we have targeted, because when you are doing a big excavator or a mining dump truck or a tractor, it's going to be operating continuously. Let's say a tractor operates 10 hours a day, a mining dump truck operates 23 hours a day, right? So we had to do immersion cooling of those batteries in order to keep them safe. And that safety also gives you a longer life cycle. On an average, if your average operating temperature goes up by 10 degrees Celsius, your life cycle goes down by 50%. Right. So you want to keep these batteries operating almost to the duration of these vehicles, which operate for a very long time, like 10 years, right? It's not like a Tesla where after every few years people feel like changing the Tesla. A tractor, if you buy it, you keep it for 10 to 20 years typically, right? So that immersion cooling, thermal management is our number one technology, right? Now we have built that same technology into making power electronics around the battery. When you build these big vehicles, or you make big vehicles make big vehicles become electrified using our technology, those big vehicles cannot move around and come to the charge station, right? You're talking about an excavator, 20-ton excavator, bigger excavator, somewhere the rate moves very, very slow, and you don't want to be taking it out and bringing it back in, right? Whatnot. So we build a mobile megawatt charger that will take the charge to your target vehicle. And this vehicle we build ourselves. So this is our vehicle. It's a 4-wheel drive, 4-wheel steering vehicle with a mobile, with a megawatt charging port, right? So we can go up to 1 megawatt on that. So what this means is the tractors that we build, we can charge from 10 to 80% in 6 minutes. The excavators that we have built, we can charge from 10 to 80% in 15 minutes, right? And so now our product line has, in the last 5 years, gone from just batteries to power electronics to now mobile megawatt charging systems, which are now in demand in many, many different industries, because people want to be able to take it and use that as a source to charge vehicles or charge drones or charge any different types of things that people would use these kind of platforms in, right? Now, the data center starts from there. ZettaWatt starts from there. Okay, what do we need in ZettaWatt is, first, what's the problem we are trying to solve, right? Is something that we got to discuss. If you're okay with it, I can jump right into that right now.
Yeah. Good time to jump into that. Yeah.
Okay. So we got approached by people from the energy grid side, from Texas, other places, where they, even a year back, they were bringing to our attention there is a problem with this data centers connecting to the grid, right? What's the problem and why it didn't exist before, right? Like data centers have been there for a while, right? So what has happened is that the scale of the data centers become bigger as a percentage of the overall grid capacity, right? So for example, the Texas grid is like 85 gigawatts right now. Now, before a single data center or a cluster of data centers, maybe 70 megawatts, 100 megawatts, something like that. Now you're talking about gigawatt data centers. And so the gigawatt data centers, as a percentage of the total grid is becoming bigger. And right now, the number of the applications to build new data centers in Texas for the next 6 years is 450 gigawatts. So their current full power is 85 gigawatts, and people are talking about 450 gigawatts, right? So there are two major problems that's happening. First is the DC load seen by these hyperscale data centers, because they're doing a lot of the LLM type of training and other types of activities in the AI space. They're having a lot of synchronicity and oscillations. So the power consumed by the racks is not continuously steady or slowly changing. It's changing very rapidly. It could change as rapidly as 50, 60 hertz, or point to all the way to 0.1 hertz, right? So when the DC side is consuming power in a very oscillatory manner, it shows up on the AC side, right? Because you're drawing power in that with that oscillation. And now if you imagine the generation of this power with the big generators and all the shafts, they're all now subject to this oscillatory pattern, and that causes a lot of fatigue failures. So the grid doesn't like it. So this is the number one problem in terms of the new wave of data centers. In the past, because even if they had this oscillatory nature, because it's a small percentage of the total grid power, you could still tolerate it. But not anymore, right? These data centers are dominating the total grid capacity. The second thing is sometimes what happens is the grid has a low voltage event, right? Like, anywhere in the world, but, I also grew up in India. Suddenly you will see that light becoming a little bit dim and then coming back, right? You've seen this many times, right? It's nothing but the grid is actually having a low voltage event. And that low voltage event could happen to anything because of a lightning strike somewhere, a squirrel ran across two wires somewhere, some random stuff. It could be far away from your substation, but it could still affect you, right? Now, what happens when the low voltage event happens is you don't go running and turn off your switch. You're just there, and as soon as the voltage event spikes back, the load is there, right? That's how the grid was designed. The grid needs to have supply equal to demand all the time, right? Approximately. So what happens with the data centers is when there is a low voltage event, just like your light bulb event, they switch automatically to backup power. So when the low voltage event comes back, the load is not there anymore for the grid to see, because the data center is operating off the generator. The grid comes back. Let's say you have a 5 gigawatt data center. I think in Vizag they're building a 5 or 10 gigawatt data center right now, India's biggest data center. So imagine there's a low voltage event on our AC grid, and this 5 to 10 gigawatts completely goes to a backup generator. And so when this low voltage dip comes back, which is very fraction of a second, it just comes back, the load is gone. So supply is not equal to demand anymore in the grid. And what happens then is your frequency goes up, right? So in US, we are at 60 hertz. And the minute you go above 60.38 hertz or something, you have to shut down everything because that becomes unstable, right? So these are the two major problems that are happening between the data center and the grid. Now, the data center people, they were more focused right now on getting land permits, clean air permits, and everything. So this is like, okay, you do everything, but then you're not going to get permission to energize, right? And even if you had gotten approval long time back, before November 2025, when it's time to energize it, they will curtail you. So they'll say, okay, you got approval for 5 gigawatts, but you're not able to adhere to my requirements. So I need to give you a much lesser power than what I approved you for, right? So we got approach for that. Now, how do you solve this problem? It requires a EV type of thinking more than anything else, right? So, in US, Toyota Prius was very popular for a very long time because it's a beautiful series hybrid, small vehicle, right? Like, saves you a little bit here and there, capitalizes on the region, right? So that's kind of EV know-how. So what you need to dampen these oscillations or take these oscillations, you need a battery somewhere in the system, which is going to be acting like a shock absorber in some sense, right? It's going to be taking your DC load fluctuations and somehow smoothing it out and then giving it to the AC side, correct? So that's where we come in, right? And these batteries are going to be working all the time, so they're going to get pretty hot. So they need thermal management, right? It's like if you take a UPS battery, for example, you have a UPS event once in a blue moon. So what would you do is you wouldn't do much thermal management of the batteries. You would let the battery discharge at a high rate, and then it's going to get a little hot, not exceeding the battery cell temperature limits. But then it has like 2 weeks or 2 months to cool down slowly by itself, right? But here you're talking about every second you're hitting it with some fluctuation. The battery has to be doing something with it. So you need to thermally manage it. And I think our DIMAAG's immersion cooling technology is one of the best in the world. It's pioneered by Ian Wright. Then comes, where do you put this battery? Right? It's just, okay, just a battery. Like, you just cannot connect a battery to a DC bus and expect it to charge and discharge. That's not how it works, right? You need a voltage difference in order to be able to do this. Now, many companies have obviously recognized that a battery is required. Some companies, very big companies, they put the battery on the AC side, correct? Expecting somehow some, it to soak in some of these oscillations. The other requirement from ERCOT and now all the other PJM and other ISOs all over USA are following is that the oscillation should be reduced to almost 99% or greater. Right. So what they specify is they want the oscillation in the AC side to be less than 10 megawatt. So for a 1 gigawatt data center, that is like 99%. Correct. So we achieve 99.7% reduction. Okay. Doesn't matter what frequency your oscillation is, how much the oscillation is, we can reduce it to 99.7%. And before I go into how we do it, let me explain how general choices are. What are the ways to do it, right? One of the ways to do it is to put a big battery on the AC side. And, it's a grid tie, put a grid tie inverter, right? So you are trying to put a battery and an inverter and trying to do that. Companies like Tesla have tried it, right? That's the Tesla Megapack solution. And as per their own documentation, they can reduce the oscillation by 70%. Correct. So it's still not sufficient. Now, other companies try to put super caps, ultra caps, right? Again, published information from some of the leading capacitor manufacturers is like they're able to get 72%, 75% reduction in oscillation. Now, one way to do it and actually make it work is to do a double conversion on the AC side. So you get the AC, you convert it into DC, into your battery, and then from your battery, you convert it back into AC and then you take it back. Correct? Now, every time you convert, there is an efficiency issue. Correct? So let's say you're a good converter, let's say 98% efficiency. So you're losing 2% and 2%, you're losing 4% all the time. Right? Imagine 10 gigawatt data center and you're losing 4% all the time, right? That's a steep penalty to pay, right? So we do it on the DC side. So our solution is actually don't muck around on the AC side. It's elegantly simple to solve it on the DC side. So we have it on the DC side. And with this, we're able to get 99.7%. Now, the reason for ZettaWatt is the industry requires more than just a battery. So it's not sufficient to say, hey, here is a battery, you go figure out how to use it, right? People want a fully integrated solution. So we said, okay, let's solve the second problem also. Our battery and our architecture solves the oscillation problem, but let's also solve the low voltage problem. And it's called voltage write-through, whether it's low voltage or high voltage, it doesn't matter. The grid may have either of those events and we need to be able to write through them. And so we did architectural change. So Ian envisioned this architecture where the switches that are there on the AC side, he removed them, right? So usually there'll be many switches, AC coming in and there's a generator backup coming in there and other things, and you'll be switching between one and the other. And that's the reason why when the low voltage event happens, you are not there. You switch to something else, right? So we removed that. So the front end, power electronics, which is basically the AC to DC converter, will then be able to handle the low voltage event without shutting off. And we figured the industry needs a fully working product, integrated product, not like piecewise. So we have partnered with some of the biggest manufacturers of some of those power electronic components, transformers, AC/DCs, and even battery manufacturers who are willing to do the battery manufacturing for our product, and put this all together as one product, as kit, right? So the input will be what they call as medium voltage, 34.5 kilovolt to 13 kilovolt. They call it medium voltage, pretty high voltage for me, right? And then the output will be 800 volt DC coming to all the customers, right? So between these 2 points, we magically, through our architecture and our battery sim and everything, our control software, how we control it, we are solving both the oscillation issue to greater than 99% and the low voltage write-through issue. And that's ZettaWatt.
So from a layperson's understanding, is it correct to say ZettaWatt will sit in between the grid and the data center?
It will actually sit on the inside it'll be more on the data center side than the AC side and the grid side, but it bridges the gap between the two.
And would you say that the 800 volt DC is increasingly becoming the default standard going forward? Is everyone on board on this?
Everybody is on board on it, but it's a different question to answer. When will this all become real, right? So for reasons we talked about, the power density per rack is just skyrocketing. NVIDIA asked the chips that in another 6 months, they will be at 1 megawatt per rack, right? If you have a 50 volt bus feeding 1 megawatt, you're looking at 20,000 amps, right? So that's not going to work. So that needs to go to 800 volt in order for your power density of your racks to go up. And so the entire ecosystem has to now create solutions for it, right? For example, the DC companies, the companies that make the chips that convert from 800 volt to 50 volt to a GPU voltage, they're all getting the chips ready right now, right? So they're all samples. So by the time they get to production, it will be sometime next year, middle of next year. So I anticipate 2028 first quarter, you're going to see people starting to have 800 volt solution. And I think everything going after that is going to be at 800 volts.
Again, sort of simplistically, if I might ask this question, is it possible for existing data centers, which are predominantly at 50 VDC, to kind of retrofit using products like ZettaWatt and move to the 800 VDC standard?
Yes. So these two problems that we talked about between the grid and the AI data centers exist at both 50 volt and 800 volt, correct? Because still, irrespective of 50 or 800 volt, you still cannot cut off the grid whenever you have a low voltage event, or whenever you have the oscillation, you cannot just pass it to the grid, right? So what we are doing is a clean solution that your data centers can have 800 volt, correct? And then we, right now on the 50 volt system, the way it happens is AC runs all through 480 volts 3-phase, and then you get a drop to your compute rack, and there are power modules inside your compute rack that converts the 480 volts 3-phase AC into a 50 volt DC, correct? So what we can provide is a 800 volt system, and then convert that 800 volt to 480 volts 3-phase so that you could retrofit and use your existing racks and everything as it is right now. So that's one way to do it, right? And there are companies that have approached us about that idea, and we have proposed that. The other idea is to actually do what we did in the 800 volt stuff at the 50 volt level. But again, we believe that the 50 volt architecture probably in the next 5 years or so is going to be phased out, right? It's going to become 800 volts. So just providing a compatibility to the 50 volt for now, and then having a full-fledged 800 volt solution going forward is the way I think the industry is going to move.
Can you talk about one or two standout innovations that you have designed and built into ZettaWatt, and also to sort of throw the story forward? Do you see that all this experience and expertise that you've accumulated, especially cooling and immersion cooling and all of that, do you think you can build solutions, or are you already building solutions in terms of cooling the racks themselves? Because that's currently a very big issue, right? Because existing data center cooling solutions, growing concerns in terms of sustainability and all of that. So how are you looking at all of this?
I think thermal management is the key to everything, right? As you're scaling, thermal management is the key. I come from a semiconductor background. My first company was semiconductor. My third company was semiconductor. So I literally can speak in terms of millivolts and milliamps, or in terms of 35 kV, right? The key is system integration. Okay. So what's happening right now in the industry is people go to a power electronics company and say, what do you have to offer? So they get a spec sheet from them on one component. They go to a battery company and say, hey, what do you have? And then they're just trying to mix and match them, put them all together and say, this is going to be their solution. While it will work, it is going to be inefficient or lacking in some way, right? It doesn't solve a functional problem the way it should be solved, or it doesn't have an efficiency that is required to run this for a longer time, right? So I believe that our thermal management is our strength across not just batteries, but also our power electronic solution. The second thing that's our strength is our system level know-how, right? For example, there are many companies that are there right now, which their whole product is, the oscillation that happens on the DC side, on the GPU side, when you're running all these LLMs and things like that. Now, they try to predict what is going to be that oscillation so that you could, take that information somehow to compensate for it, right? Ahead of time. Now, yes, it's a small piece of the overall solution. It may be an important piece, but if you're looking at a full system level, it's much easier to do it from natively from a battery hardware kind of stuff. We don't need software to step in to try to save the day. The reason I say that is I think LLM is a dead end, right? I know LLMs are riding high right now, and the coolest thing to do right now is to walk into a big VC and say, I'm going to do an LLM and get like $1 billion investment, right? And I'm not the only one. I think a lot of well-known people in the industry feel like LLMs are not what they are made out to be, right? The reason is that LLMs are inefficient in terms of how much power they need to figure out something, correct? So then, because you're banking on just making these LLMs bigger and bigger and bigger and more monstrous, then you need bigger and bigger data centers and more power. You quickly reach a point where it's impossible. Back in 2018, when we were doing this AI thing for a big company, I did a study. This back in 2018 when LLMs were not really what they are today. What happens if all these AI claims become real? People can actually do what they're claiming. I calculated at the time that we would need about 226 nuclear plants, right? Well, what is it right now, right? So at the end of it, if the cost of compute is more than the cost of human, what did you really achieve, right? So where I'm going with this is any solution right now that is customized to just deal with the LLM problems, better watch out. Because some smart guy sitting in a garage somewhere is going to come up with something that's much better than an LLM, right? Now, his pattern is going to be different because he's going to use power in a different way because his compute is in a different way. So your system needs to handle all of that, right? It needs to be a native way of handling it. It should not be a kludge, right? I think that's the right word. You don't patch up here and there to solve some problem. People try to do this. So they put a capacitor bank to solve high frequency problems. They put a battery backup to solve different frequency oscillations and whatnot. I think the best solution is the simplest solution, the most elegant solution. So as the algorithms are changing, what happened in the last 5 years, right? Why all this sudden craze is because ChatGPT was bold enough, or OpenAI was bold enough to release that ChatGPT as buggy as it was at the time. So try it out, right? It was November 2022? People tried it. Yes, now suddenly they got a feel that it's much different than the Google search engine, correct? So I think the way people talk about this is, Google is like a librarian, right? It's going to give you the answers in like a books, but while ChatGPT is generating the answers, right? But there are limits to this generation, right? It's a blurry line here. Is it actually generation or is it really, right? What else is going on? But don't take me wrong here. I think LLMs are provided a great deal of productivity improvement on many, many, many different fields, right? Even I use ChatGPT whenever I need to for summarizing, or instead of me reading through 50 Google articles to figure out, something that I want, I'm able to query much, much better using ChatGPT. But what I am 100% confident of is this is not our North Star. this is just starting out right now. And like in 10 years' time, if you go ask people about LLM, I think they'll laugh at you. Right. But the same data center is going to be there. Irrespective of LLM or whatever is coming in the future, we need to be ready for it. And I think the grid, the chips of semiconductors have kept pace with the kind of compute that is required for these LLMs, but the grid has not. Right, the grid was built for residential purposes first, and then it accommodated industrial applications. Some manufacturing things and everything, but nothing like a data center.
I'm just gonna circle back to the innovations part that I asked you about. I'm sorry, my previous question was too long, so I kind of distracted you from the innovations part myself. That's one of my flaws when I do these interviews. Mindful of that. So, to your mind, what would you say was like the top 2-3 most valuable innovations that are, proprietary to DIMAAG today? And building on top of those innovations, what would you say is your sort of big picture opportunity over the next 3 to 5 years?
Okay. So first of all, as thermal management, right? Thermal management across every part of it. So you're able to keep the temperature down. And second is the amount of power you required to do the thermal management is also smaller. So you talk about how much power is needed for the cooling system. That becomes, much, much smaller because you're doing, immersion cooling. The second innovation is we have removed a lot of unnecessary parts. We have removed a lot of converters from one voltage to the other voltage, DC converters. A lot of those things have been removed. Each one of them helps you reduce your capex cost. It reduces your opex cost because your efficiency goes up, right? So the architecture is the innovation, right? How everything is moved to the DC side to make things much, much simpler. The third part of it is how we control those power electronics, our software that controls those power electronics such that the grid to the load is kept in balance, right? So this is what helps us achieve that 99.7% reduction in the DC load oscillation to the AC side. So these are the three major things. Now, the fourth thing is how to put all this in a system integration manner, right? So we pride ourselves that we have built full system vehicles in less than 1 year. So the tractor that we build from the date the president of the company signed the contract to the date that we let him drive that vehicle was 8 months. This includes gears, chassis, batteries, software, full vehicle, and all that, right? So we keep the startup speed and advantage while having a full vertical stack know-how, right? And leveraging things. So going forward, I believe that more and more things are going to have a battery as part of the system solution. And it's just not only data centers, right? For example, let's say mining dump trucks, right? We are working on making them a series hybrid, right? So just because they're going down the hill and coming up the hill, right? So when you go down the hill, you can use the energy, convert it into useful electric energy in the battery and store it. We can save anywhere from $500,000 to $1 million per dump truck per year, correct? So there are two things here when you're using batteries. Sometimes it makes economical sense to use a battery. In very few cases. But there are cases like this mining dump truck, right? Like now trying to reduce the load oscillations in the data center side. It makes definite sense, right? So we do believe that things which are considered to be old-fashioned, power electronics, batteries, those were not the cool things even 5 years back. It's all come back, right? So I do think the next 10 years is going to be the energy wave, right? You got to feed all these things which are going to require more energy, and we're sitting right there in terms of batteries which are going to be used for storage or used for load smoothing or applications like that. But whatever be the next problem that comes up, I'm very confident that DIMAAG is going to be well situated to take it on because we have full vertical stack know-how.
Okay, I want to ask you a couple of questions with respect to India.
Yes, sir.
Today, do you see it as a market or maybe a nascent market for your products? Do you already have a team here doing some of your engineering, R&D? Just walk us through any plans or give us an update.
So we have an office in India, more than 100 people in Bangalore. So we're already a big presence in India. On the business side, we are knocking on many doors. India has been, the India that I left a long time back is not the India today. Correct? Much different. So there's a lot of opportunities now, right? And so we're knocking on the doors. Even the big US hyperscalers, everything, are the ones who are collaborating with the Indian companies to build even the Vizag data center or other activities that are going on. So the other aspect of it is we do hope to manufacture a lot of the parts that we are building for ZettaWatt in India. So we don't expect India to be only an R&D house, but we also expect it to be a manufacturing place for DIMAAG.
In terms of the overall so-called umbrella deep tech landscape, what is your assessment of how folks in the US, especially in Silicon Valley, both entrepreneurs like yourself, your network, and the global VCs, some of the biggest ones sit in the US. What is your assessment of how they're looking at the deep tech landscape in India today compared to, say, maybe 5 years ago?
Well, I think compared to 10 years back, let's go 10 years back, I think they're respected. I don't think Indian high-tech initiatives are third world anymore. They are dominating the world, right? So the key, though, is going to be vertical stack integration. I think for the longest time, even 10 years back, 15 years back, all these semiconductor companies set up shop in Bangalore, everything, they were doing it for specific horizontal layers, not a full vertical layer. And now things have changed in the semiconductor industry, but also in this full system level, like what DIMAAG is doing. I think the entire thing can be done in India. So from my understanding, if from all my venture capitalist friends and everything, if a startup in India comes up with an idea, I think they're equally likely to fund it as a company in Silicon Valley, right? I don't think there is any difference anymore.
Any one example when you say vertical stack integration, from your own experience, what would you say has been the most sort of successful playbook that deep tech entrepreneurs in India can look at, especially the ones who are focused on, hard, unglamorous hardware engineering products, like you said, which is now coming back?
Yeah. So, I think 10 years back, India did successfully make a lot of very big companies in just software, marketplace type of solutions and everything, right? But slowly now, I think there's a lot of companies which were dominant in the hardware side, right? A lot of companies make different parts, very, very successfully. I think they are taking on more of a system integration play. I don't see software companies trying to take on hardware. I think hardware companies taking on software and system is coming about. And these hardware companies are the guys who are feeding all the hardware companies on the rest of the world. Correct. So it's not like they are just a local operation. They're a worldwide operation. It's just that they need backing. Correct. So if a company has been there for like last 10 years or 15 years, right? It's possible sometimes the venture capitalists, the investment community does not think of them as a sexy investment. They would rather invest in two college students from IIT Madras rather than a company that has been around for 15 years, but just found the opportunity to change the world, right? So take NVIDIA, for example. NVIDIA was not doing very well not too long back, right? And suddenly this AI wave kind of came at the right time for them, and their chips were the right type of semiconductors that was required. So I think opportunity is knocking for many of the companies in India. Now the question is, how big is their vision? How big do their entrepreneurs think they can take that company? And that requires, I think, support from general, media, right? Then if media writes nice articles about them, oh, this is going to be a unicorn company in India and things like that, it it allows the entrepreneur to dream that they can do it, irrespective of where they are located. And I think the disadvantages of operating in India versus operating in Silicon Valley have merged quite a bit, right? As I said, I've had India operation for DIMAAG since 2019, I believe. So we have been around for 7 years in India. So I think there's a lot of good talent there, and we use talent wherever we can find it. We have operations in Japan, and we also have operations in Silicon Valley.
What would you say? I mean, roughly, I know that it's not very clear cut or siloed, but in general, what kind of work is best done in India? What work do you still do in the US or in Japan at DIMAAG?
Okay, so in India, we have done robotics, we have touched hardware there, we have done software, traditional software, of course, right? India is known for it. We do a lot of AI optimization, which is also used in our not just purely application layer AI, but another AI there, right? But now, as I said, we are growing our company to have a manufacturing capability in India for parts, and we also have manufacturing and system integration in USA, right? So I don't see too much of a difference between the two. But Japan is a lot of business development and customer support and engineering, right? So that's a different set of requirements there than the split between India and the US. But I think increasingly any talent that we are looking for, we can find it in India and in the USA, and less frequently in Japan.
I was just about to follow up with missing pieces in India, especially on know-how. But you are saying that you are more likely to find talent these days. Can you talk about that a bit? I mean, important missing pieces at the ecosystem level for a company like DIMAAG, a lot of hardware-focused engineering company, but also plenty of sophisticated software that's going into it, system-level stuff. So important missing pieces in the Indian ecosystem.
I wouldn't say anything is missing, but okay, I'm a very old man. Okay, so I left India in early 90s, right? At the time, you go to a college, you spend 4 years, you study some standard subjects and everything, and then it's up to you to make a life out of what you learn, right? And most likely, what you learn got nothing to do with your first job. So then you go do something. All that education gave you is an ability to educate yourself in the future. That's basically what it did, right? Now imagine I want to become an expert in power electronics, but I studied some other topic, correct? I have so many online options to be able to learn that very quickly. So if a person is interested in learning, your college or none of those teachers, none of those things matter anymore. You can learn, right? Because there is content out there everywhere. When India did this way back in 80s, 90s, we kind of mass manufactured engineers, correct? We started more and more engineering colleges. We said, okay, let's make everybody an engineer. And, the most brilliant guy in any country will be brilliant, correct? So, you take the smartest guy in US, I think will match the smartest guy in India or smartest guy in Japan or anywhere else, right? But on an average, can we bring the average up? Right? That's what India successfully did in the 80s and the 90s, in my opinion, right? I see like why people like me had the opportunity to come to US to study and everything is because India invested in people like us, right? I think the education paradigm is shifting, correct? Now it's up to individuals more so than a government backing, subsidies for education and things like that. I'm not an economic guy. I'm not a political guy. I'm just giving you what I think is my honest read on how things happen based on my own experiences, right? So, thing is, people like me who came out of that system have started 7 companies, benefited a lot of people who worked for us in these companies. Many people in America, many people in India, many people in other parts of the world, right? But to get that, we need to stand on the shoulders of something, and we stood on the shoulders of the education system that we had at the time. But now I see kids everywhere, US and definitely in India, they have the ability to figure out things so quickly because the content, like we don't have to sit through 6 months of a professor talking and most of us sleeping in the class, right? You just have like, okay, I can figure this out in 1 week's time period, right? If I just dedicate myself to it. So I think we are in a very unique moment in time in human evolution where I can see a dramatic increase acceleration in the rate of learning. I know Indians are really good at that, right? So I don't think anything is deficient, but in terms of ability to provide them the infrastructure, right? So let's say some kid in India wants to do the next thing after LLM, right? He has an idea, has to do it, but it still requires scale, right? All that I'm saying is LLM has a point at which it just cannot scale. But some other ABC technology is coming up. He needs the compute infrastructure, right? India needs to have it. Like, what's the point if he runs that compute infrastructure in a different country's server, and then you're having all these, geopolitical, I don't want to talk about those things, but you want to have infrastructure to support people who are having those kind of, ambitions, right? But I think enough people will have such kind of ideas and ambitions. The government just needs to support them. And right now, I think the way they are compensated, top engineers everywhere are getting compensated almost in the same way. Gone are the days where India was a low-cost center. That's not how it's envisioned for certain industries, right? Especially in this AI industry, the way that we are looking at it, definitely the compensation is on par. So the kids will have the ambition to go for it. Correct? I think that's the thing, right? In Silicon Valley, the thing I figured is that, hey, I can meet with anybody who I have heard of, right? And at the end, realize that they're no different than me, which gives me the confidence I might also have a shot of doing something, right? I think that moment has already come worldwide, right? It's no more that there is this, elite learning system somewhere in some part of the world that we are not part of. I think all the differences have disappeared.
Okay, that's an interesting insight. Quite deep, actually, if folks want to think about that. Did you always want to be an entrepreneur?
Oh, yeah. So I come from a teacher's family, right? So my dad was a professor, is a PhD engineering. So he was a principal director of colleges in South India. So I come from an educational background, right? But I kind of saw in my dad, teaching is in his blood, right? That's what he was teaching. But if you look at the industry, there was so much that could, have been possible, right? So when we look at the times when we come from the 60s, employment in 60s, 70s, where it was very difficult, it was very important to have a job, a government job, a pension after that. Like, those kind of thoughts were because of the state of the economy, right, and the country at the time. Then my generation is like, okay, you know what, we can work in the private industry, right? It's like working in the private industry is not like a death sentence, right? It's okay. And then very quickly you see, within 10 years after, late 90s and early 2000s, they said we can start our own company, right? So I don't feel like working for a very big company for a very long period of time because my contribution doesn't make or break that company, right? I could come to the office, be on the browser all day, and I'm not going to break the company, or I create the best thing in the planet. They have so many good things going on that I'm not going to be able to contribute. I like that everything I do, I have an impact, right? Well, it may not be technical, it may not be business, it may be HR, it may be something which is important for a company at different points in life. So I didn't want to work for a place where my contribution is not going to count. Yeah.
Okay, excellent. I know I have to let you go soon, so I'm gonna bring it back to DIMAAG and give us a sense of your vision for DIMAAG over the next 5 years, let's say.
So one of the things that I look forward to is to develop products that stand the test of time. Correct. So, 10 years, 15 years from now, when I'm retired, when I'm looking around something, oh, that's something that I had a bit to do with something that touches, So, as I said, I started from my master's was in algorithms. My first company was in semiconductor. My third company was in converting algorithms to chips, right? And now I'm on the power system. So I would like to think I'm uniquely positioned to go from this high power to the chip side, right? And to optimize this value chain. And if through that, we are able to create a solution that solves some of these critical showstopper issues, and if that hopefully stands the test of time, I'll be very satisfied. So for me, it's not that DIMAAG has to become the biggest company in the planet, either in terms of size or monetary, valuation or things like that. But we contributed something that solves a real problem. That's all that I need.
That's it for this conversation. You'll find the relevant links to Satish's bio and DIMAAG's website in the show notes. You can support my work by subscribing to my posts at indiatechreport.in. I'm Hari Hartley. Thank you for listening.